Hello and welcome to this presentation brought to you by the Mapping and Benchmarking Annex of the IEA 4E Implementing Agreement. This is one of a series of presentations which summarise the results of our benchmarking reports, which look at the energy efficiency of a domestic appliance or commercial equipment, comparing and contrasting energy efficiency levels between the different participating countries around the world. This particular presentation is regarding the standby power of domestic appliances and is brought to you using data produced and made available by our colleagues within the IEA 4E program who run the Standby Power Annex. This presentation will last about 20 minutes, and we will start with a look at the data sources that are used to inform the analysis, and in particular this is looking at the quality of that data and highlighting the caveats and aspects to bear in mind when drawing conclusions from the data that you'll see. We then look at the analysis process that was used to produce the graphs, and then we will look briefly at the policies that are already in place around the world regarding standby power, and then we'll go into the results, comparing and contrasting energy efficiency and power consumption for 10 different products and product groups, and we'll conclude with some observations and conclusions arising from the analysis. Firstly, however, we'll present a fairly simplistic definition of what we mean by standby power. I mean, there are comprehensive and complex definitions available in some of the test methodologies already published around the world regarding standby power, but for the purposes of this presentation we'll just consider standby power to mean when a product is connected to a power source and is able to be reactivated by either a network or a remote signal. And so the power that's consumed by products in this state may be making available information or status display. It might be enabling the product to store information on a continuous basis. It may provide safety functions, or it may simply be to allow the product to be part of a network and to be woken by that network and ready to perform its function. The data sources that we used for this analysis made available a total of standby power measurements on 26,000 different products, and that included individual measurements with a total of 37,000. The data covers 19 different countries, but 13 of those are in the EU, and for the purposes of the graphs within this presentation we group the 13 EU countries together into one block. The data arose from a range of government and regional research projects and also included some data that was provided for the televisions analysis, which is published separately by the Mapping and Benchmarking Annex. The countries that made available the data are shown on this pie chart. Around a third of the data actually comes from Australia and New Zealand, and that country has for many years monitored standby power and provides a very good time series of data. Just under a third of the data comes from the EU, and then we have USA, Canada, the Republic of Korea, and a small amount from India as well. Now, the projects that gave rise to this data are shown in the table here. One of the major projects was in fact an Asia-Pacific Partnership sponsored project, which provided data for Australia, Canada, the EU, India, Republic of Korea and USA. But this is supplemented by several other project data sources, including a buildings survey project in Canada. It includes a European Commission sponsored project called Selena, which covered 12 countries in the EU. But we also have data from a couple of government databases and from the California Energy Commission within the USA. So quite a range of different projects gave rise to the data, but many of these had very similar methodologies and indeed cooperated in the design of their projects. And these were the in-shop measurements carried out through the Asia Pacific Partnership Project, through Selena, and through India. The methodologies for all of those was very similar, with clearly defined approaches to making the measurements, with a well-coordinated data gathering methodology, which gave rise to a pretty comprehensive and well-indexed data set. So as I've mentioned, there were 26,000 products included in the analysis, and these broke down into 156 product types. And this chart here shows the number of measurements by product type. So along the bottom are listed the products. In fact, the ones that you can see on this graph are not all of them. The display has only shown every third or fourth title, but it does give you a feel for the range of products that are included, and they're arranged from left to right in descending order of the number of measurements that were recorded. So LCD TVs was certainly the most numerous product in terms of the measurements, with over 3,500 measurements. And I think you can fairly clearly see from this graph that a fairly small proportion of the total number of products actually accounted for the vast majority of the data within all of the data sets. So in terms of the coverage of the products, these 156 different products account for around about 80% of all household standby consumption within these countries that were studied. And the top 10 products account for around 70% of the total data set. So as you can see, there's a very long tail of products with little data, and those it's difficult to do very much with that long tail of data. But however, we do want to focus on the products that are more important and more interesting. If we take a quick look at the categories of data, the categories of products rather, televisions accounted for 37% of all the measurements, so we did have a very robust data set for televisions, and that enabled us to do some more detailed analysis on televisions than we've managed to do for the other product groups. Home audio accounted for 11%, but as we will discuss shortly when we look at the results, it does cover quite a mixed bag of products within that category. So there are many ways of slicing and dicing the products that make up this total data set. They could be grouped in categories like this, or we could home in on particular product types, and basically we wanted to make sure that the analysis gave a useful set of data. So this pie chart is basically just summarizing the data you've just seen, giving a visual impression of the size of the relative sizes of the groups of the categories of product. But when we try to focus on how to present data, the sort of criteria that we use to decide how to divide the data were these. Firstly, we needed to make sure that there was a reasonable quantity of data for any of the particular products or categories we analysed. We were interested in trends over a number of years to see what's happening to the efficiency or the standby power of that product group. So we're looking for data that spans several years. Ideally, we really are looking to compare and contrast countries' performance. So we are looking for data sets that had 3 or more countries with data. Clearly, the overall aim of the work is to assist policymakers to make policy more effective. So we want to choose products that are of current political policy interest. And finally, we did want to make sure that the data we present has reasonable consistency and value in terms of its analysis. So we did take that into account as well when selecting the products and categories to present to you. Basically, we put together a top 10 of products and categories that together accounted for just over 70% of the data. So we made use of most of the data. And these are the products and categories that we selected, the top 10. Televisions, by far the biggest group. We did present a graph on home audio. We looked at washing machines. We looked at microwave ovens, DVD and Blu-ray players and recorders. We looked at computer displays. And then the last 4 are getting to be smaller data sets with less than 700 products, and that was notebook PCs, external power supplies, multifunction devices, which are the printers and scanners, and set-top boxes was the final of the top 10, but that only accounted for just over 400 products, so it's a smaller data set. The right-hand column there flags the products that are the subject of other analysis that has been published or will be published by the Mapping and Benchmarking Annex in due course, and where possible we did draw data across from those analyses as well into this analysis. The approach we took to carrying out the analysis was firstly to unify the names used for each of the products and product types. So we wanted to make sure that we were comparing like with like, and this enabled the merging of the data sets. We then grouped the products by categories in some cases, and we chose to either analyze passive standby or off-mode power for each of those different product groups or categories. And basically we chose the mode which had the most significant amount of data available. Whilst some products did have network standby data, that actually accounted for less than 1% of the data, and so we have not done any detailed analysis at all of network power under this analysis. Now, in terms of the statistical analysis and the calculation of averages, if there was no recorded power figure against any particular product, then that was ignored. But for many products, there was actually a 0 recorded in the data set against the standby power, and we took this to mean that the reading was below the resolution of the meter that was used, and so we took it as a real reading and we counted that 0 as part of the calculation of averages. Because all of the measurements were taken to a well-defined and controlled process and procedure, and it was a simple case of measuring using a power meter, there was no normalization or adjustment required to make the data from different countries and different projects directly comparable. We assumed that they were all inherently directly comparable. Now, as I mentioned, we have done some additional, more detailed analysis for televisions because that had by far the largest quantity of data. And one of the things we did to make this data more representative of each country was actually to effectively sales weight the data that we got according to the proportion of sales in each country accounted for by the different screen technologies. So for LCD, for plasma and for CRT, for each country we calculated an average for each screen technology and then sales weighted to provide a total average standby power for that country or region. So this was a quasi sales weighting in order to give more robust averages for each country regarding televisions. Now, in the graphs that we will be looking at shortly, you will see different line types joining the dots on the graphs, and this actually indicates the data quality or how robust the data is for each country. Firstly, if we were to have had any robust data, the data that we call robust, that would be sales weighted data, then that would have a solid line joining the dots. But in fact, none of the data that we had was truly sales weighted, notwithstanding the sort of the weighting of screen technologies which I've just described, but that isn't a true sales weighting of power, and none of the data sets were classed by us as robust. The other two data qualities that we use generally in the analysis that we carry out under this annex, we have indicative and illustrative. Now, for the purposes of this particular analysis, our definition of indicative data was if there is an average of at least 60 products used to create the average for that point on the graph. And if there were over 25 products that contributed to the average of that point, then we join the lines with the dotted lines that you can see there. And finally, if there were between 5 and 25 products on average in each data bin, or an average to generate each point on the graph for that country, we didn't give it a formal grading, but we have left the points on the graph just for reference purposes. And basically, if there were 5 or less products for any given year for each product, then we did not consider that as part of the analysis. It's just simply not robust enough to merit inclusion in the analysis. So data quality overall was pretty good. We have data sets that were consistently produced to a recognizable and well-documented methodology. And 3/4 of those measurements were actually done in shops. So whilst it's not measured to the formal harmonized test methodology, such as 62087 for standby, we do feel that it is pretty robust data, particularly given the size of the data sets. And whilst there was some small variation in the definition of standby modes across the different projects, we didn't consider those to be significantly damaging to the robustness of the data. But having said that, there are some significant caveats that must be borne in mind when looking at these results. And these are summarized in these 4 points here. These are clearly results measured in a sample of shops. They're not full market surveys, and so the samples in those shops may not be representative of the full market at all. Data quantity is highly variable between the different sets, between the different countries, and by product, and indeed also it varies significantly by year for any given product. And so there is a lot of inconsistency, and that must be borne in mind. Now, in particular, when you're looking at long-term data sets, there is no guarantee that the same types of product are being measured in any given or between consecutive years within any country, and so that may give rise to changes in average power. Similarly, different retailers were used in many of the measurement activities from year to year, so that may also it may also influence the typical efficiency, typical standby powers measured. So trends must be treated with caution, particularly for the graphs which show a category of product as opposed to looking at individual products, because that has additional scope for significant changes in the mix of products included from year to year, and we'll explain a couple of those in more detail as we go through the graphs. So next, we'll just very briefly summarize the policies that are in place in the participating countries around the world. It was back in the 1980s that standby was first identified as a significant energy issue, and then following that some policies started to pick up on standby as an issue, and the IEA published its 1 watt plan back in 1999, which started to lay out a formal global policy approach template, a template that different countries could start to adopt for policies in their own regions or countries. And then followed further standby policies in various countries becoming more comprehensive and more robust. And perhaps one of the better examples of a comprehensive policy approach is actually that has been implemented in the Republic of Korea, and that first emerged in 2005 and is arguably the most comprehensive package, which incorporated voluntary labeling for products, then warning labels coming in for products that exceeded a certain standby power, and finally in 2009 in the Republic of Korea mandatory minimum requirements were introduced, and this was backed up by a comprehensive awareness campaign working with manufacturers, and you'll see in the graphs perhaps evidence of some of the impacts of that comprehensive approach. Going forward, in 2010 we started to see horizontal minimum requirements for standby, and this means the policies that impose a minimum requirement on a wide range of different products. So it's tackling the standby issue across a range of products with one measure, and this where it is possible to do this within the regulatory framework is starting to become more prevalent as a way of tackling standby. And so that summarizes the different policies in place around the world, and more information on these policies is given in the benchmarking report, which you can find online, and that's signposted at the end of this presentation. So starting to look at the actual data from products, we're starting with the first and most numerous product in our analysis. So this is the first of the top 10, and that's televisions. Looking at passive power, this data set shows a significant and very clear fall in standby power over the period from 2001, 2002 through to 2011. It's falling in all of the countries that we looked at, and has dropped from over 4 watts down to less than 1 watt in most of those countries now. Korea and also more recently the USA have achieved the best average performance, the lowest standby, which has been less than 1 watt from around 2006, in fact. The results that were measured from India have shown a significantly higher standby power, but once again a very significant drop. It's possible that's associated with the change in screen technologies. Back in 2008, 95% of televisions in India of new sales were CRT, but in 2011 that proportion had dropped to 60%, so the newer technologies were coming in, and these tend to be more efficient and use less standby power, and that's probably what we're seeing in these results. The EU results possibly show between 2008 and 2009 the effect of the standby minimum requirements, so that could account for that last drop in the EU data. But it does seem that there's a correlation between the standby power shown by the Korean televisions up to 2005, followed by a very significant drop. 2005, if you remember, is when that campaign, the comprehensive policy campaign in Korea, was started. Finally, the Australian television average had reached below 1 watt by 2011, and in fact at that stage 99% of televisions were performing at that level. And this Australian data set enables some extra insight into the way the improvement has occurred over the years, and that's the next slide. So this graph shows the left-hand vertical axis shows the share of total measurements accounted for, and the horizontal axis is the passive power level. So what this is saying is that whilst there are more televisions on the market with between 0 and 1 watt, there is quite a significant number of products with much higher than 1 watt standby power. In fact, about a third of the televisions in this data set from 2007 had a standby between 1 watt and 6 watt, and in fact the highest was up at around 20 watts. But as we move forward through the years, the proportion that have a lower standby power increases significantly, until in 2011 99% of these televisions were at or below 1 watt. Moving on to the next most numerous product category in terms of the analysis, home audio. This graph shows a lot of scatter, and this is probably due to there being a mixed bag of different audio products within this category. It contains radios, CD, cassette decks, integrated stereos, etc. It doesn't include any portable equipment, but even so, there is a wide range of possible products in this category, and it's likely that the mix of products in any given year changes significantly, and probably is what gives rise to the large amount of scatter that you see, ranging between less than 1 watt up to nearly 6 watts as an average for any given year. So it's difficult to draw any firm conclusions from that particular data set, although it is the second most numerous in our analysis. The Australian part of this data set is perhaps a little easier to show a trend from, but once again it really does contain a different mix of products in many given years, and that accounts for the spikiness as the trend appears to drop from 2002 down to 2011. Washing machines were looked at for off-mode performance, and we can see in this data set relative stability since 2003. No major trends visible in that data set. although we could suggest that all countries are by 2011 at or below 1 watt in off mode. Microwave ovens we looked at for passive standby, and we do have an apparent slight reduction for Australia, India and the EU. Perhaps there is an increase showing for Canada, but this is not significant and the data sets are not numerous enough to be really sure of that rising trend in Canada. But once again, we do see that the Republic of Korea is significantly ahead of the rest of the market, although it is a fairly small data set. Interestingly, the Indian microwave ovens that were measured are up with the better performers in this particular category. This next slide looks at DVD and Blu-ray players and player recorders and looks at their passive standby performance. And probably one of the main reasons for the spiky, inconsistent performance year on year is that the grouping of players together with player recorders may not be conducive to consistent passive standby power. We almost certainly are seeing a difference of product types year to year, and we may even be seeing seasonal effects of when in that particular year the testing was done due to the predominance of certain types of product at certain types of year, and we're probably seeing the effects of Blu-ray versus DVD, and indeed we're also seeing the introduction of recorders first appearing in the market in about 2005, and that may have also introduced some skew in these results. Recorders consuming or having a higher standby power, and so different functionality and introducing other influences that skew the results in any given year. The next category is notebook PCs, and we have seen in this data apparently an improving trend that reaches below 1 watt since 2009. The samples from India actually showed in excess of 6 watt average, even up to 18 watt in 2011, but this was not it's not a very small sample, but having discussed with the project managers of this particular piece of analysis, it does seem possible that the sample tested in India in the shops were actually products that had their battery charging at that point, which would certainly give rise to a much higher measured power. The products on display in India were not always switched on, and so once they were switched on, the battery was likely to begin charging and so give higher readings. Another example of the sorts of influences and caveats that have to be borne in mind for this sort of analysis. Looking at computer displays, these are products which have very low variation between different countries. It's a very uniform product around the world, and there was very little scatter, but a fairly clear, slowly improving trend, and certainly below 0.5 watts by 2011. Now we're getting into the products for which the quantity of data was not so high. This is multifunction devices, so this is printers, scanners. The Australian dataset, highly variable. We don't really understand why that was quite so variable, but perhaps we are seeing an indication of a falling trend, at least up until the last couple of years, but we probably do have a mix of different functionalities coming in there. Trends in these product groups do vary year to year in terms of the functionality. We're possibly seeing with the EU dataset there the influence of the standby regulation. But yeah, difficult to draw any firm conclusions on that particular product group. External power supplies in their passive standby or no load power state, looking to be well below 1 watt in all of the countries we looked at. And indeed that has been true since 2007. The dataset from India was not numerous enough to be plotted on this particular graph. Finally, looking at set-top boxes and their passive standby performance, we firstly should note that the scale on the left-hand vertical axis here goes from 0 to 25 watts. The previous graphs you've looked at have all been from 0 to 7 watts, so this is a much larger variation in power, and it really does show a very wide scatter and inconsistency of performance over the years, going from 0 or nearly 0 up to 23 watts for Canada there. And we do believe that this actually reflects the very different functionality which is dominant in each of those markets. Arguably these are really not similar products, perhaps those that consume in the order of 5 watts compared to those that are consuming 20 to 25 watts in standby. The functionality is likely to be very different that these are providing. And this product group, the set-top boxes, is actually the subject of an analysis which is being carried out during 2013 in more detail under the IEA 4E Mapping and Benchmarking Annex. So we're rounding off with some key issues and observations drawn from the data that you've seen. Firstly, the average standby power has certainly improved over time in 8 of the 10 product groups that we looked at. Those that have not shown significant improvement are microwave ovens and set-top boxes. We've seen standby power levels being less than 3 watts since 2007 for 8 of the 10 product groups looked at as well. Those that did not achieve less than 3 watts were set-top boxes and home audio. And in many of the graphs that we've looked at, the Republic of Korea has shown consistently good or best performance amongst the countries looked at, with California also averaging similar levels for many of those product groups in more recent years. The Korean results show a TV standby level between 20 and 50% lower than the other countries, and arguably this could be due to the very comprehensive supporting policies that have been in place there and the early signalling and collaboration with manufacturers to work on this issue. And it does appear that these sorts of policies have been able to push markets further and faster than is evident in the countries where market-driven efforts alone have contributed to the improvements. Looking at general policy observations coming out of this, it does now appear that horizontal standby policy measures seem the most appropriate to tackle the very wide range of different types of product, electrical and electronic, which are on and emerging onto the markets. But this sort of horizontal measure is not possible in all regulatory frameworks, but countries such as Australia and in the EU, this has proven to be the approach going forward. Particular products that are still posing challenges for policymakers include set-top boxes, where we are seeing standby rates up to 25 watts. We certainly seem to have some high power standby within the home audio set, but the analysis was not able to draw firm conclusions on the subtypes of product within there. And certainly network standby is a complex challenge for policymakers and is the subject of a number of initiatives going on around the world. And indeed, this is also the subject of particular analysis by our colleagues in the Standby Power Annex under the IEA 4E implementing agreement. But it does appear that the high-level international commitment to standby as a policy issue has probably contributed to the significant success that we've seen in a lot of this analysis. So we've also tried to draw a few observations and conclusions in terms of the type of data that's been made available and the projects that gave rise to this. There's no doubt that having these strategic and long-term programs to look at standby certainly gives rise to consistent and detailed data sets. And the cooperation that's been evident across between the different countries has made the data sets highly comparable and consistent, and has made it much easier to look at overall global trends. However, even given that carefully designed process, there were a lot of inconsistencies in the product scope, which can make the conclusions less robust, and it can make it difficult to see exactly what's going on. And perhaps in terms of going forwards, there might usefully be focus on perhaps a smaller number of products and product types, and to focus resources on those rather than the very wide range of products that have been measured. And it's quite challenging to draw conclusions from such a very broad range of products all at once. And finally, there were a few points that we could draw out, particularly on televisions, which did achieve a consistent and significant reduction in standby power. Levels were around 4 watts in the year 2000, but had dropped to well under 1 watt by 2011. And the Republic of Korea was achieving 20 to 50% better standby power levels than others, although the USA did match this. And worth pointing out that despite the average being under 1 watt, the datasets did show of the order of 1% of products failing to comply with the local regulations. And it's important that those regulations are enforced to protect the investment made by the companies that produce the products that comply. And indeed, on televisions and several of the other product groups, there has to be policy focus to prevent energy savings being undermined by products that fail to meet the requirement. So this is one report of a number of benchmarking reports on different products that are available through the website. This is a list of the currently available reports, and there will be another one coming along during 2013 on set-top boxes. If you want to get in touch with us at the Mapping and Benchmarking Annex, then please do drop us an email, ask any questions that you're interested in, and we would be pleased to receive your questions or comments and feedback. I hope you found this interesting, and we look forward to bringing you further presentations and benchmarking documents in due course. Thank you.